Okay, so that was sad. We're gonna do this again. It's gonna be like a bad rerun for me, but it's okay. It's new to you. Okay, here we go. First of all, this guy. Look, they give me an equation. This is really kind of exciting news. They give me an equation and they ask you to write in factored form. Well, you used to not know how to do that. And I hope this is the right one I'm supposed to do. What did you do first? We did 1 and 2, and I did 3, 4, and 5. Yeah, just 6 and 7. Okay, sorry. False alarm. But they do tell me one of the roots. And if you look here at the graph, this should make sense. You could have done second calculate zeros if they didn't give you a graph. But look, -2 is nice. That would have shown up nicely on your table. But do you see these two guys? These are like in-betweeners. So you can see them, so they're real, but I'm betting there's some sort of square root situation happening here. So then how do I factor it? Well, what you can do what you know. If you know -2 is a root, then you know x plus 2 is a factor. And this is why we did synthetic division, guys. So just divide this guy by x plus 2 by putting -2 in the box, and then whatever is left is a factor. So we drop the 1 and we have our party. We multiply, we add, we multiply, we add, we multiply, and you better get a remainder of 0, and we do. And you have a number x and x squared. So that means x plus 2 times x squared minus 4x plus 1 equals that guy. And we did technically factor it. Now, this guy cannot factor further, which is fine, but we can still get the roots from it by solving it. You can solve it using quadratic formula, or you can complete the square, which is what I'm going to do because this is a nice even b. So I'm going to change the x squared minus 4x to an x minus 2 squared. That would put 4 in the corner. I have to get to 3. So I have to get to 1. 4 minus 3 is 1, and that will equal 0. If you remember those boxes from way back when. And now we solve it. We add 3. X minus 2 squared equals 3. Square root both sides. So x minus 2 equals plus or minus square root of 3. And there's those square roots I was thinking about. And then you add 2. So you get 2 plus the square root of 3 and 2 minus the square root of 3. And we know those always come in conjugate pairs, so that makes sense. If you wanted to write factored form with these guys, you are welcome to, but this is good enough. M behavior, you can get from the picture. As x goes to the left, it's going down to -infinity. It's your regular standard snake baby. And then it's going up to the right. As it goes to the right, it goes up. The domain of all polynomials is -infinity to positive infinity. And the range for all odd degree polynomials is -infinity to positive infinity. Not odd functions, but odd degree polynomials, these snake babies. Okay, so let's talk about number 7. And number 7 is going to be a good one because this one actually is going to be an even function. That was in the notes the other day, and some people had asked me some questions. This is not an even function. I'm such an idiot. This one is going to be an odd function. I'm sorry. I already did this once. This will be an odd function. It's the only odd function that shows up in these problems. And then I looked back to make sure, and actually question 2 is, it's neither even or odd, but question 2 kind of looks like it would be even, but because it doesn't have y-axis symmetry, it's neither. So everything is neither until you get to question 5. Question 5 is even, and then this one is going to be an odd one for us. We can factor it. There's a GCF. They have an x in common. So that gives me an x, and that will leave an x squared minus 2. That does not factor further. So one of the roots is definitely 0, and then the last 2 will come from solving this guy. X squared minus 2 equals 0. Well, if you add 2, you get x squared equals 2. Square root both sides, you get plus or minus the square root of 2. And those come in conjugate pairs, so that makes sense. It is a cubic, so it's a snake baby. So the M behavior you can get from the sketch. As it goes to the left, this guy goes down. And it goes to the right, it goes up. The domain and range of all odd degree polynomials are -infinity to positive infinity. And at this time, you would go to your technology. I bet mine's still there from before. Y equals x cubed minus 2x. There it is. And you graph it. So yeah, this has 180 rotational symmetry. You don't know quite for sure until you check out the table. The table can see, do you see how that's like 321? Well, if you change the sign, you had to change that sign. That's how it tells you. -1, 1, change that sign, you have to change that sign. That means it's odd, it has that symmetry. It would be nice to know these two maximum points just for your sketch. Second, calculate max number 4. Enter, enter. We did this a few times already. Okay, so it's like -0.8 up a little bit past 1. That's just for the sketch. So if you change both those signs, it would be there as well. And that would be enough for you to graph it. The square root of 2, the negative square root of 2, you could put approximation dots there as well. And I think I said it went up about, point it like about up here. And it goes through 0. Okay. So, ooh, I'm just gonna get a little baby graph. It's not very good, but that's fine. Okay, so that's it for the notes. 310 will be next week. This is all you're doing for the rest of this week. 310 will be next week, and then I'm gonna make a review video for your test, and you'll take your test next week. And then after that, we're going to look at an optional thing for the final. I don't think I'm going to require everyone to do it. Some of you are kind of checking out. So we'll discuss those plans after you guys take your last test for me.